things we don't know. Putting science in your hands.
Why are the planets so different?
If you were to take the 8 planets in our solar system and look at them as a whole, there would be 2 obvious groupings. The first of these are the giant planets, which are well deserving of their names, hundreds of times larger than the others and with thousands of times more mass.
The spectacular contrast between the 4 giants, Jupiter, Saturn, Uranus and Neptune, and the other planets is fairly easy to explain. Before the planets were formed, all the material which they now contain was spread out in a giant protoplanetary disk.
The 4 gas giants formed outside the snow line of our early solar system, where it was cold enough to allow the relatively abundant volatile substances like water or ammonia to condense out. This gave the first baby planets in this region of the disk plenty of liquid and solid material to sweep up to form bigger and bigger planets in a process we call accretion. This process is a runaway one. Gaining more mass means more gravity means gaining more mass, and hence we get the giant planets, huge balls of gaseous material that, we think, contain some kind of rocky or metallic core at their centre.
Some questions remain about their formation, particularly about their potential travels through the disk early in their lives, but that's not what we're here to look at right now. Instead, let's look at the planets we swept aside earlier, otherwise known as the terrestrial planets, Mercury, Venus, Earth and Mars.
These planets share many similarities, but have many striking differences as well. The terrestrial planets are all formed of essentially the same stuff, silicate minerals and heavy iron cores, elements that could exist as solids and liquids in the warm inner early solar system. So in essence, they are all made of rock. Their exact composition varies slightly, perhaps due to the distribution of different materials in the early solar disk, but we can consider them essentially the same.
Venus, Earth and Mars also have similar proportions of volatile elements, and these are materials that become gas at comparably low temperatures like water. These substances the giant planets have plenty of, but the terrestrial planets must have collected them later in their lives. Exactly where these elements came from is a big question in planetary science. It may be that comets hit the planets, bringing these elements along with them. These 3 planets have roughly the same proportions of things like water and carbon, although they're contained within different types of reservoir, in some cases the atmospheres, in others the rocks. And here's where we see the first striking difference.
Mercury, the closest planet to the Sun, is too small and far, far too hot to retain a substantial atmosphere, and the incessant solar radiation it receives has stripped away any atmosphere that it may once have had. This lack of atmosphere means that Mercury undergoes massive temperature variations between its dark and sunward-facing sides.
Why the terrestrial planets are the size they are is something of a mystery. It may simply be chance that the particular planetesimals that formed them were larger or smaller, or it may have been due to the specific distribution of material in the solar nebula. But Mercury is the smallest, and combined with being so close to the Sun, this means it has next to no atmosphere.
Mars is the next largest, and has a thin but definitely present atmosphere, mainly composed of carbon dioxide. Venus and the Earth are almost identical in size, and in fact are nearly twins in many more ways, but the 2 most similar planets look incredibly different to a casual observer. Venus, shrouded in clouds and acid haze, is the hottest place in the solar system, with an atmosphere so thick it could crush you many times over. Compared to Earth, Venus is a hellish world, while Mars is cold and dead. but under slightly different circumstances, these three planets might have been much more similar.
Since Venus and Earth are almost exactly the same size, it can't have been the strength of their gravity that caused the difference. Instead, as Venus is slightly closer to the Sun, it was probably just a little bit hotter than Earth in its youth. And if it didn't have such a thick atmosphere, it would probably still only be that little bit hotter. Yet the dense, sulphurous carbon dioxide atmosphere causes an intense greenhouse effect, heating the whole planet up to several hundred degrees. The thick atmosphere traps this heat and distributes it all around the planet, creating...
An important question, then, is where Venus got this tremendously thick atmosphere from. In fact, it may have been that the small difference in temperature from being slightly closer to the Sun is enough to have a massively disproportionate effect. The carbonate-silicate cycle, which governs the conversion between these two types of rock, is strongly dependent on temperature. Higher temperatures tends to mean that more silicate minerals are formed, along with the release of carbon dioxide. This carbon dioxide is a strong greenhouse gas, meaning that its release will increase the temperature a little bit more, initiating a vicious circle that has left Venus such an unappealing place to travel to. If Venus had any oceans early in its history, their evaporation would have compounded this effect, as water vapour is also an incredibly strong greenhouse gas.
The Earth, slightly further away from the Sun, and therefore slightly cooler, has undergone the opposite. Most of the carbon on our planet is locked away in carbonate rocks, leaving our atmosphere relatively clear of it, although this wouldn't have been true for certain periods of our planet's past. In fact, we actually need a little bit of greenhouse warming to make our planet anything other than a frigid, ice-covered world.
Mars is at the other end of the scale. Further away from the Sun and slightly smaller, which meant it will have cooled down quicker, it is now a cold, dead world. Its thin carbon dioxide atmosphere offers little to no warming effect, since most of it has been lost to the ravaging effects of the solar wind.
Our Earth sits in a potentially precarious place. Could the input of carbon dioxide and other greenhouse gases into our atmosphere turn us one day into another Venus? Or will our planet suffer the same fate as Mars and end up cold and dead?